When working on a small building project, several electrical considerations need attention. Firstly, concerning appliance circuits, treat compact appliances as full-size units due to their potential to draw significant power. This ensures adequate circuit capacity, preventing overloads and fire risks. 220 amp small appliance circuits are not necessarily required in this situation. With only 4 outlets, a single 15 amp circuit may suffice. Remember, ground fault circuit interrupter protection is mandatory, and one ground fault circuit interrupter outlet can protect all 5 outlets. Secondly, regarding storage area receptacles, omitting them is permissible initially. Receptacles are not obligatory in storage spaces unless dedicated equipment or appliances need them. If future receptacle installation is foreseen, reserve space in the wall for a junction box and conduit to simplify later additions without major renovations. Thirdly, when it comes to smoke detectors, a single unit in the hallway should adequately cover the area. Position the smoke detector in the hallway following local building codes and manufacturer guidelines. Additional considerations include the lighting load, which must be factored into the electrical service size. The electrical panel must possess enough capacity for all necessary electrical circuits. Proper grounding for all electrical equipment and appliances is crucial. Always adhere to local building codes and electrical standards when planning and installing the electrical system. For appliance circuits, it's vital to understand how different appliances contribute to the overall load. Small appliances, despite their size, can have power demands comparable to larger models. For example, a small ice maker might draw a similar amount of power as a full-sized refrigerator during its freezing cycle. Similarly, a compact dishwasher might consume a considerable amount of electricity during its heating and drying phases. Therefore, underestimating the power requirements of these appliances can lead to overloaded circuits and potential safety hazards. A 15 amp circuit, which is a common type in residential and small commercial settings, can typically handle a continuous load of up to 12 amps, which is 80% of the circuit's capacity. This means that the combined load of all appliances and other devices connected to the circuit should not exceed 12 amps for extended periods. If the total load exceeds this limit, the circuit breaker may trip, interrupting power to the circuit. To prevent overloads, it's crucial to carefully calculate the power consumption of each appliance and device connected to the circuit. The power consumption is usually indicated on a label on the appliance or device, typically in watts. To convert watts to amps, divide the power in watts by the voltage of the circuit, which is typically 120 volts in the United States. For example, an appliance that consumes 600 watts would draw 5 amps on a 120 volt circuit. By adding up the current draw of all appliances and devices on the circuit, you can determine whether the total load is within the 12 amp limit. If the total load is close to or exceeds the limit, it may be necessary to redistribute some of the appliances and devices to other circuits or to install additional circuits to accommodate the load. Ground fault circuit interrupter protection is essential in areas where there is a risk of electric shock, such as near water sources. Ground fault circuit interrupter outlets are designed to detect even small imbalances in the current flowing through a circuit, which can indicate a ground fault. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. Ground fault circuit interrupter outlets quickly interrupt the flow of electricity when a ground fault is detected, preventing serious injury or death. In the case of the 4 outlets mentioned, a single ground fault circuit interrupter outlet can provide protection for all of them if they are wired in series. This means that the ground fault circuit interrupter outlet is installed as the first outlet in the circuit, and the other outlets are wired downstream from it. When a ground fault is detected at any of the outlets, the ground fault circuit interrupter outlet will trip, interrupting power to all of the outlets in the circuit. Concerning storage area receptacles, it's important to consider the potential future needs of the space. While receptacles may not be required initially, it's possible that the space could be used for different purposes in the future, which may require the use of electrical equipment or appliances. For example, the space could be used as a workshop, a home office, or a hobby room, all of which would require the use of electrical outlets. If you anticipate that the space may be used for such purposes in the future, it's a good idea to install receptacles during the initial construction phase. This will save time and money in the long run, as it will avoid the need to make major renovations later on. If you choose to omit receptacles during the initial construction phase, it's important to leave space in the wall for a junction box and conduit. This will make it easier to add receptacles later without having to tear down the wall. The junction box should be sized appropriately to accommodate the wiring and connections for the receptacles, and the conduit should be run from the junction box to a nearby electrical panel or circuit. When installing the receptacles, it's important to follow all applicable electrical codes and standards. This includes using the correct type of wiring, grounding the receptacles properly, and installing ground fault circuit interrupter protection if required. For smoke detectors, proper placement is critical for ensuring effective detection of smoke and fire. Smoke detectors should be installed on every level of a building, including the basement, and in every sleeping area. They should also be installed in hallways outside of sleeping areas. In the case of the small building with 3 spaces and 1 hallway, a single smoke detector in the hallway should be sufficient to cover the area, provided that the hallway is centrally located and unobstructed. The smoke detector should be placed in the hallway in accordance with local building codes and manufacturer's instructions. Typically, this means placing the smoke detector on the ceiling or high in the wall, away from corners and other obstructions. It's also important to test the smoke detector regularly to ensure that it is functioning properly. This can be done by pressing the test button on the smoke detector. If the smoke detector does not sound an alarm when the test button is pressed, it may need to be replaced. In addition to the considerations mentioned above, there are several other electrical factors that should be taken into account when working on a small building project. One important factor is the lighting load. The lighting load refers to the total amount of power consumed by all of the lighting fixtures in a building. This load should be considered when sizing the electrical service, which is the amount of power that is supplied to the building from the utility company. If the lighting load is too high, it may be necessary to upgrade the electrical service to accommodate the load. Another important factor is the electrical panel. The electrical panel is the main distribution point for electricity in the building. It contains circuit breakers that protect the electrical circuits from overloads and short circuits. The electrical panel should have sufficient capacity for all of the electrical circuits required for the building, including the appliance circuits, the receptacle circuits, and the lighting circuits. If the electrical panel is too small, it may be necessary to install a larger panel to accommodate the load. Proper grounding is also essential for electrical safety. Grounding provides a path for electricity to flow safely to ground in the event of a fault, preventing electric shock and damage to equipment. All electrical equipment and appliances should be properly grounded in accordance with electrical codes and standards. Finally, it's important to always follow local building codes and electrical standards when designing and installing the electrical system. Building codes and electrical standards are designed to ensure the safety of buildings and their occupants. Failure to follow these codes and standards can result in serious injury or death. In summary, when working on a small building project, it's important to carefully consider all of the electrical factors involved. This includes appliance circuits, storage receptacles, smoke detectors, lighting load, electrical panel capacity, grounding, and building codes. By taking these factors into account, you can ensure that the electrical system is safe, reliable, and code compliant. Remember that even seemingly small appliances can have significant power demands, and it's crucial to avoid overloading circuits. Ground fault circuit interrupter protection is essential in areas where there is a risk of electric shock, and smoke detectors should be properly placed and tested regularly. Always follow local building codes and electrical standards to ensure the safety of the building and its occupants. Leaving space for future receptacle installations can save time and money in the long run. By carefully planning and executing the electrical work, you can create a safe and functional electrical system for the small building. Before commencing any electrical work, it is highly advisable to consult with a qualified electrician to ensure that all work is performed safely and in compliance with all applicable codes and regulations. Electricians have the knowledge and experience to properly assess the electrical needs of the building and to design and install an electrical system that meets those needs safely and reliably. They can also provide guidance on selecting the appropriate electrical equipment and appliances, and they can ensure that all work is properly inspected and approved by the local authorities. Attempting to perform electrical work without the proper training and experience can be extremely dangerous and can result in serious injury or death. It can also lead to code violations and fines. Therefore, it is always best to leave electrical work to the professionals. Consider that lighting, while seemingly straightforward, also has nuances to consider. The type of lighting impacts the load, with light-emitting diode lighting being far more efficient than incandescent or even fluorescent lighting. This means that for the same level of illumination, light-emitting diode lights will draw significantly less power, reducing the overall load in the electrical system. When selecting lighting fixtures, it's important to choose energy-efficient models that will minimize power consumption. Also, consider the placement of lighting fixtures to ensure that the space is adequately illuminated without excessive use of electricity. The electrical panel is the heart of the electrical system, distributing power to all of the circuits in the building. It's important to choose an electrical panel that is large enough to accommodate all of the circuits that will be required, both now and in the future. The electrical panel should also be properly grounded to ensure electrical safety. The grounding system provides a path for electricity to flow safely to ground in the event of a fault, preventing electric shock and damage to equipment. The grounding system should be properly installed and maintained in accordance with electrical codes and standards. Building codes and electrical standards are constantly evolving to reflect new technologies and best practices. It's important to stay up to date on the latest codes and standards to ensure that the electrical system is safe and code compliant. The National Electrical Code, or NEC, is a widely adopted set of electrical standards that provides guidance on the safe installation of electrical systems. Local building codes may also have additional requirements that must be followed. In addition to the specific considerations mentioned above, there are some general best practices that should be followed when working on any electrical project. Firstly, always turn off the power to the circuit before working on it. This can be done by switching off the circuit breaker at the electrical panel. Secondly, use properly insulated tools and equipment. This will help to prevent electric shock. Thirdly, never work on electrical systems when you are wet or standing in water. This greatly increases the risk of electric shock. Fourthly, if you are not sure how to do something, ask for help from a qualified electrician. It's always better to be safe than sorry. Fifthly, inspect all electrical work carefully before turning the power back on. Make sure that all connections are tight and that there are no exposed wires. Sixthly, test all ground fault circuit interrupt outlets to make sure that they are working properly. This can be done by pressing the test button on the ground fault circuit interrupter outlet. If the ground fault circuit interrupter outlet does not trip, it may need to be replaced. By following these best practices, you can minimize the risk of electrical accidents and ensure that the electrical system is safe and reliable. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take precautions to protect yourself and others from electric shock.